Chapter 12, Major Rehabilitation, UFC 346001. Unified Facility Criteria, Design Petroleum Facility, Department of Defense, United States of America, approved for the public release and distributed and unlimited. Chapter 12, Major Rehabilitation. Introduction. Decisions concerning the major rehabilitation will be based on the economic, mission, safety, and environmental factors. It is intended that the chapter to mandate the rehabilitation only to provide guidance for the decision made most common reason for the rehabilitation, meet the environmental needs, extend the usable life of the facility and tank of the major component with the tank of the service for rehabilitation review other UFCs. However, they consider each of the change based on the merits and its compliance with the UFC. This UFC is not intended for the UFC to initiate the changing and upgrading the existing facility by initiating the facility improvement with major rehabilitation, fuel project recommendation, physical condition, and survey be conducted with the survey condition for the facility goal and identifying the major deficiency, prioritizing the work required, contacting appropriate command, fuels, energizing facility engineer, components command, the Navy Civil Engineering, Surface Command, Army Corps Engineering, Regional Design Office for the Navy Air Stations, Marine Corps Air Stations, including representation from Navy Air with the survey team, the most is coordinated with the major rehabilitation property proposal of the major being based master plan. 12.2 General Requirements. Chapter 2 General Description contains the important information for the fueling facility design, the modification and fueling system without the first becoming completely familiar with Chapter 2 of the UFC. 12.3 Above ground fuel storage tank rehabilitation. Existing above ground tanks can be modified to meet the fuel quality standards, safety requirements, environmental regulations to maintain structural integrity. Above ground storage tanks ensure the complete and usable facility, ensure all the design and accomplishment engineering will regularly engage with the tank and modification and have all the specifications reviewed. They have API standard 653 certified inspector complete all the tank modifications, repairs, alterations, inspection in accordance with the API standard 653 and API standard 650. Require a new strapping table after the major tank of the rehabilitation above ground vertical tank inspection prior to the modification of the tank. Conduct a thorough inspection consistent with the requirements of the API standard 653. The inspection will reveal any of the repairs needed to be made in order to comply with the current regulations. 1232 Increase the manhole size. Many older above ground vertical tanks have inadequate sized shelled manholes. These ventilation equipment requirements for the maintenance have created with a number of 36 inches diameter and holes. They do not exist. Consider rehabilitation provided in accordance with Chapter 8 of this UFC. Chapter 3.3 Replacing the tank floor. Replacing any tank floors only with the API standard 653 inspection, including magnet fuel oxidant leakage test, indicates the life of the bottom that has been expired. That the bottom requires more minimum repairs, upgrades, and insufficient fuel quality. Problems do not pounding water exist. Contact the service headquarters with the guidance whenever the tank bottom replaces should be complete. Comply with the current design standards, including double bottom and single bottom liner. In case of the shallow tank with the single bottom with the remainder of service with the bottom warrants replaced unless other provisions are programmed with the Millicon SRM project that has been approved to replace the tank of the bottom, conducting an analysis for the existing tank under local conditions to determine the most desirable approach. The type of the new bottom of the installed with the number of the factors included, condition of the existing bottom of the tank foundation shell condition with the amount of the tank capacity which can be lost. Install the double replacement in accordance with the API standard 653. Install the slope of the bottom either above the existing bottom of the user can accept the resulting loss. The tank of the capacity, removing the existing bottom needed to solve the new slope of the bottom in its place, and the slope of the 5% is preferred, not required in the conditions, but the cost make a recommended slope of impracticable, providing a minimal slope of 2%. Either the case, install impermeable liner in accordance with the Department of Defense standard design AW78 2427 as well as the leak detection between the old two floors. If technology exists, that it may be cost effective to raise the tank and the foundation to accomplish the undertake modifications, the repairs, adding containment inner liner and telltale system, cathodic protection ring wall, etc. 12331 Double bottom with wash side sand layer and liner. Clean, repair existing tank bottom, install the liner at the top of the existing tank bottom of the bed. Add 4 to 6 inches silica sand layer on the top of the liner and install the new steel tank bottom on the top of the sand layer. Prefer the 8th of this UFC suitable sand criteria. Lead the detection consistent with the telltale spouted of the PVC pipe with the sand layers, the regularly spaced with the intervals extending out through the outer shell of the tank, provided with the cathode protection, sacrificial anodes impressed with the current closed liner with the maximum clearance within the tank bottom, and install the adequate numbers of cathodic protection reference cells between the two bottom 12332 double bottom concrete layer with a new steel bottom. The clean repair with the existing tank bottom installed liner over the top of the existing tank bottom of the 4 to 6 inches of the fiber reinforced loop lump supplements, typically 3000 psi Gs. Concrete over the liner of the existing bottom shape with the concrete to provide with the adequate slope. Install the new steel tank bottom on the top of the concrete. Slope the concrete towards the sump forward the series of the grooves along with the top surface to collect any of the product which may leak from the new bottom. Slope the channels and collection point of the pipe extending and observe wall well provided with the concrete with the alkaline over 13 or higher. 12333 double steel bottom. Clean repair existing tank at the place of the structural support system at the top of the existing tank bottom. Install the new tank bottom. Design the structural support system to prevent excessive defection for the loads of the primary and new tank at the bottom. If they're all interstitial spacing between the two tank at the bottom of the tank of the collecting end product with the leak of the purge the interstitial space between the two bottoms of the nitrogen. Remove the oxygen for those creating a non-corrosive, non-combustible environment. Elimination condensation of oxygen with space and minimizing the corrosion formation from the upper and the bottom to provide leak detection with sensors which can detect the pressure change with the space. The pressure indicates the result from the leak of the upper tank of the product within the space. The decrease in the pressure indicates the leak of the steel failure has occurred within the logo or tank at the bottom. 12334 single bottom with the liner. Remove the existing tank with the bottom to prepare the sub base with the bearing capacity. Place the sand layer with the sub base to support the primary tank at the bottom. Install all the liner with the slope of the center line with the sump. Place the 12-inch layer with the sand at the top of the liner. Install the new tank at the bottom of the tank. Up with the same layer of the liner sump of the collection with the points of the leak at the bottom, consisting of the drain pipe leading to the observation wall. Alternate method of the telltale spotted PVC stainless steel pipe to according to the Department of Defense Standard Design AW78 2420 to provide cathode protection superficial anodes and press with the current closure of the liner and alloy maximum clearance for the new tank bottoms. Install adequate number of the cathodic protection reference cells between the two bottoms before the cathodic protection in the sand layer approximately 6 inches below the tank at the bottom above the liner. 12334 replacing floating roof tanks with a fixed roof. The floating roof requires the significant repair work correlated between the economic repair for any of the reason considered unserviceable by the API standard 653 inspection. Consider replacing the fixed cone light roof with an internal seal with a honeycomb cell floating as well as required in the 21512 or 215.2 for the fixed cone relief added with the existing tank with the roof. Manufacturer design must determine the tank with sufficient strength to support the new roof. If the shell is structurally insufficient, geodesic dome may be considered. Install the supported roofs in accordance with the API standard 650 and API standard 653. Department of Standard Design AW78 2427. In general, all opening floating roof tanks containing aviation fuel should be programmed to receive a cover as well as should the tank in northern climates where the snow and ice is the problem. 1235 product recovery system. Provide storage pumps and piping valves and tanks to collect the recover the return the use of aviation turbine fuel which otherwise becomes waste, including the tank like the fuel, water, air mixture for the tank equipment, sumps, equipment with the drains, high point vents and low point drains, any other equipment for which the fuel water mixtures can be collected. Separate the fuel and water portion, filter the fuel portion with bulk storage tanks. Do not discharge the water portion of the surface of water. Additional treatment permits the treat of the water portion of the wastewater. Refer to the Chapter 2 of the UFC information handling wastewater in accordance with the Department of Standard Design AW78 2427. Coatings. And tank coating projects minimize the generalization of hazardous waste associated with the coating removal. Some of the alternative traditional sandblasting, including shot blasting, chemical stripping, high pressure washing, carbon dioxide chemical strip, stabilizer, additive pressure process, design, maintenance, painting of the both interior and exterior should be based on the coating of the condition survey. Decision noted by the USGS 099713.15, 099713.17, 099713.27. The evaluation of the shell containment should be based on not only the condition needed for the coating of the shell, but the evaluation of impairment with the corrosion pressure. Still, all corrosion pressure on the shelling coats is generally fairly low, therefore the same the need of the coating thickness, integrity that is required for the floor ceiling with the Chapter 8 of the UFC. Additional information on the exterior coating of the storage wall tanks. Recoat the portion of the tank that is already coated. When the tank is taken out of the surface for the inspection repairs, inspect the underside of the roof for rust. If conditions merit, the coated underside of the roof for the conformance with Chapter 8 of the UFC. Chapter 3.7 isolation valves. Require the tank isolation valve to prevent the accidental release of the fuel in environmental above-ground tank storage of the 12,000 gallons, provided with a double black bleed tank valves located between the tank shelf and the high-level shelf valves. 12.3.8 alarms and high-level shut-off valves. The equipment of the storage tanks means to prevent the adequate and accident overfill design according to the Department of Defense standards AW78 2427 for the Chapter 8 of the UFC the applicable requirements of the alarms valve installations. 12.4 above ground operating tanks and major rehabilitation are required with required existing underground operation tanks conform with the Title 40 CFR Part 280 to Title 40 CFR Part 281. Applicable state and local underground storage tank regulation, minimum provided leak detection, cathodic protection, overall protection, a collateral study of the cutoff of the other tanks necessary for the construction features make it possible to comply. 12.4.1 manholes provide 36-inch diameter manhole for the tank's extension names, next and internal leaders with required for the cleaning and inspection provided minimum of one manhole for the tank between 1,000 gallons and 5,000 gallons provided minimum of two manholes for the tank larger than 5,000 gallons provided manhole containment sumps for all manholes. 12.4.2 interior coatings coating of underground operating tanks are in accordance with the Chapter 8 of the UFC. The Chapter 12.5 hydrant system. The decision concerning major rehabilitation of the existing direct fuel refueling system will be made by servicing headquarters. The paragraph addresses existing the direct aircraft refueling system type 1 and 2, which can be rehabilitated, modified to meet the fuel quality, standard safety requirements, mission requirements, environmental regulations. Also, the design should be accomplished with the environmental firm regularly engaged with the design of the direct aircraft fueling system provision of Chapter 4 of the UFC as applicable. 12.5.1 pump to replace an existing pump to meet the increased fuel demands, repump including the complete bearing replacement, additional bowls increased with the impeller size replacement, mechanical seal shaft length, the shortening of the match replacement of the tanks. In most cases, the additional capacity can only be achieved with the total pump replacement, re-engagement of the piping. Consider the pump replacement where, due to the equipment of the condition, it is more economical to replace than to rebuild. The pump, the most replacement must also be resultant with the higher efficiency units with lower power or demands and increased spare of the parts available. 12.5.2 existing filter separators must be applicable to meeting the requirements of the EI specification 1581 edition 5. Existing filter separator vessels built to earlier editions of API 1581 may be able to reutilize the EI specification 1581 edition H5. Callus separator elements with possible replacement elements should meet the standard size described by the DESC XP2. The contact the service headquarters for the guidance to replace the existing vessels and cannot be converted with the EI specification 1581 edition 5 elements of visual EI specification 1581 edition 5 elements failed to meet the quality standards of the issue. The filter separator should be given the priority for the upgrade of the standalone upgrade of the filter separators and mandatory on any of the rehabilitation project. 12.5.3 fuel quality monitors. Existing quality monitors will be removed. The quality monitor elements integrated within the came in time with the fuel additives FS2 aviation turbine fuel casting fuel quality issuances. 12.5.4 the pumping house and the hydrant system is typically of the Petro and the Petro circuit in 1958. It's designed with the ultra utilized hardwired high voltage mechanical relays control system and installed with the pump house lateral control pits, the emergency stop pit activation system with the high voltage elements. Exposure to the fuels deteriorate the controlling system wiring, rendering it no longer reliable to safe to operate. Consider control systems replacement whenever the significant portion of the pump house is required with the safety electrical codes indicating the hard heads that exist. Generally hardwired relay logic system expensive to build and maintain do not offer the flexibility of the PLC. The base of the system and the control system should be low voltage design incorporating industrial standard PLCs. Control facilities are situated with the pump housing non-subject to automated fuel. The facility has a positive ventilation, no explosion proof. The fixtures are incorporated with the design. Existing control wire probably deteriorated number conditions. The no longer intrinsically and replace the controlling wire with a possible running of the controlling wiring of the overhead continuity necessary replacing the kill switch. Emergency stop circuits as part of the pump house rehabilitation cable wiring system. It is easier to install, troubleshoot, and be considered whenever the wiring is in hydrant system is replaced. 12.5.5 electrical systems replace secondary electrical systems including light motor conductors, motor control centers. The part of the pump house repairs to ensure the circuit for the pump of the house is exposed with the possibility of automatic atomized fuel. The compound employs the provision of NFPA 30 has the classified as Class 1 Division 1 motor control center is isolated from the pump house, not subject to the atomized fuel. The facility of the positive ventilation with the deteriorated non-explosion proof the inletting of the fixture being incorporated in the design. Existing secondary wiring is properly deteriorated. Numerous continuities are no longer intrinsically safe. To replace the motor wing with whenever possible, no. Run the control wing over the heated continuity. 12.5 Lateral control pits. Lateral control pits are typically concrete structure and heavy metal hinged lids containing valve, the pump filters, and piping associated with the supply with the fuel pump house hydrant outlet. Repair the placing that prevent the accident release of the aviation turbine, environmental water filter, and filterization spot slope pit floors of the sump provide manually operated slump pump stage with water removal. Use either the rolling lightweight hinged aluminum pit lids with the watertight design complete with the Department of Defense standard. Designs AW702428. A1257 distribution pipe and minimize the unlined carbon steel pipe, especially with the jet aircraft. None of the alternatives exist with the reduced exposure to the aviation turbine fuel unlined with the carbon steel pipe. One option is the internal coating existing system without pipe removal. Instituting coatings and then prevented with the fuel degradation. However, the fuel filtration must be provided by the aircraft either with the mobile or fixed filter separated. Another option is to provide piping in the non-ferrous material stainless steel. Consider the option reducing the flow with the acceptability. 12.5.8 Diaphragm control valves. Consider reusing the existing diaphragm control valves whenever possible. Diaphragm control valves are typically refurbished or original manufactured by a factory authorized repair facility for less than replacement cost. Each of these ensure they refurbish or modify to replace the pilot assembly tubing solenoids to meet the specification outlined with the Department of Defense AW782428. The minimum replacement non-ferrous pilot tube assembly of the stainless steel unit provide the stainless steel roll tubing replacement involved with the components of the valve body of the carbon steel requires the service heads, quarters. From the valve body should be sandblasted and cleaned and replaced coated in the plane in carbon steel bodies to meet the Department of Defense design AW782428. 12.5.9 Hydrant outlets. Remove the place existing hydrant outlets connection with the Buckeye API adapters. Provision API adapters ensure compatibility with the refueling equipment and if adequate pressure control regulating the surge in accordance with the Department of Defense standards design AW782428 does not exist for the hydrant pit with the lateral control pit. Install the control valve either in the location. 12.6 Dike and liners of basins. Dike liners basins do not comply with the requirements of the UFC. The Title 40, Part 112 of State Local Spill Contamination Regulation potential for accidental fuel discharge existing repair replacing existing structure. The provision Chapter 8 of the UFC are applicable. The general dikes do not retain rainwater. Improve the necessary leak detection when rehabilitation fuel facility installs the leak detection as necessary as detailed in Chapter 2 of the UFC. Chapter 12.8 The cathodic protection rehabilitation any facility installing upgrading cathodic protection, ensuring the cathodic protection is designed of the NACE and certified corrosion specialist, cathodic protection specialist, registered professional corrosion engineer, or install the cathodic protection on all steel structures, including but not limited to the above-ground storage tanks, underground storage tanks, underground piping system. The provisions Chapter 2 and 8 of the UFC are applicable. 12.9 Isolation valve provided with the piping consistent of the control valve with the permanent isolation of equipment maintenance and repair. Provide additional valve with the relocated condition necessary to conduct the hydrostatic test. Provide manually operated valves except with the motor operated specified or authorized applicable standards, drawings, technical specifications. Use a double block bleed. Type of the isolation valve separation with the products over the tank shell contamination ATS over 12,000 gallons only when piping goes over the bellow or above the below ground with the pier tank at the storage at other locations. The vertical periodic and pressure testing with the piping with opening frequent opening type of the isolation valves may be used for less critical application for the double blade shut-off valves is not required. Before adding the isolation valve, they evaluating the pipe system, make a modification to prevent pressure buildup caused by the thermal expansion. Remove the paragraph with the relay valve of Chapter 9 of the USC, except that they service the tank for tactical refueler field stand with the paragraph that does not apply to the system. However, to Chapter 7 of the USC, unless otherwise service to headquarters. Chapter 10, 1210, soil, groundwater remediation, monitor, storage, disposal of petroleum contaminated soil disturbed during the rehabilitation according to the state and local environmental regulations. Collect and test if appropriate. Treat petroleum contaminated groundwater removed during the dewatering by only one of the following methods: off-site disposal of the industrial waste facility, on-site treatment with the portable groundwater treatment system, treatment through oil water separator, treatment with the sanitary sewer, Prior to selecting treatment method, review the state and local environmental regulations, consult facility and alternatives for requirements required on-site treatment and disposal of liquid and petroleum gas facilities, the required liquid petroleum gas, back wells, ale wells, all existing thread piping, pipeline inspection conducting pipeline inspection in accordance with the API 570 and H7 and SPO 0169. 12.12.2 Smart picking, determining how the pipeline requires the rehabilitation information of the pipeline structural integrity. The essential one method of survey of the condition of the pipeline is to use smart pigs. 12.12.2.1 General. The smart intelligent pig is one of the very instrumented tools using one or more of the physical, electrical, mechanical principles, recording, measuring information, position, relatively serviceability, animals. Pipeline smart pigs can detect correct metal curves, the metal loss, curvature, bends, other types available, can map the profile, detect leaks, perform photographic inspection, sample product, use smart pigs, and the required modifying of the pipe, increasing the radius of sharp elbows, eliminating obstruction caused by the type that are not fully port type. 12.2.2 12.12.2.2 types. The three basic types of smart pigs: ultrasonic magnetic flux leakage and eddy current. The ultrasonic magnetic flux leakage eddy current pigs can be used for liquid pipelines, alternative form of ultrasonic inspection, electromagnetic acoustic transducer, EMAT. EMAT can be used either by liquid or gas pipeline. The magnetic flux can also be used in gas pipelines. Prior to choosing the smart pig, consider the expected result, cost of various options, check with the piping condition. 12.13. The following is a checklist of items considered with the major rehabilitation: above ground storage tank rehabilitation, API standard 653 inspection, 36-inch diameter manhole maintenance, add double bottom repair, slope tank floor repair and replace floating roof, product recovery system, internal external coating, tank isolation, overfill protection, corrosion protection, tank bottom leak detection, automatic tank gauge system, thermal expansion release, underground storage tank, 36-inch diameter manholes, leak detection, corrosion protection, overfill protection, interior coating, aviation hydrant system rehabilitation, repair and replace API standard 610, upgrade filter separator to comply with the EI specification 1581 edition 5, remove the automatic water drains from the filter separator, repair and replace control system, repair and replace electrical systems, repair and replace lateral control valve pits and lids, and including the impervious liner, internal coating with a carbon steel distribution pipe, refurb the diaphragm control hydrant outlets, the API adapters, replace lubricated valve switching the non-lubricated truck off and loading, truck fill and offload, and sands ground deadband, the high-level shutoff system, panographic converters from 3 to 4 inches, the low-profile filters, fusible link butterflies. These valves are not required permitted on Air Force projects. Piping the pressure relief of the contaminated tank, the updated meter diaphragm control valve, the adequate piping system, the grounding, adequate spill collection, contamination, underground spent military filter separators to comply with the EI specification 1581 edition 5. The issued filters have prior to over the receipt filters. Remove automatic water drain with the filter separator. Ensure the liquid drain with the separator is properly handled. Add isolation and blind flanges to the other system. Use a smart peg to determine the condition of the distribution piping. Monitor and remove disposal petroleum, contaminated soil, groundwater spill, contamination, collection, control, containment areas, dikes and equipment pail, adds, fill stands, etc. In previous lineage of the dikes and contaminated areas, catch basins, whenever the federal, state, and local regulations refer to the Chapter 2 of the UFC information, design, sizing, oil, water, separated treatment, stormwater discharge, contamination areas, and air dikes, area fill stands, equipment, etc. Chapter 3, fueling facility temporary deactivation.